Hi, I'm Neeraj, CTO of Bluzelle, and here's Paul, who's going to be doing our demo for Sprint highlight number 38.
Hi there, I'm Paul and I do C++ coding at Bluzelle. I'm going to show you today our common language runtime, which we're using to support many different languages to talk to the Bluzelle Swarm. The language runtime is written in C++, and today I'm also going to show you a Python script, which is going to be talking to that C++ runtime and through there to the Swarm, which you can see running down the bottom over here. So this Python test little program here imports our library. It's running in a debugger right now, so I'll just show you where we are. We're just about to call a method to create a database, which gives us something that we can use then to create keys and values and all that kind of good stuff. So when we make this call, initially what it does is it goes into a little Python shim library that we built, which sits on top of the C++ library and marshals the calls between them. And what that actually does in this case is it calls a method that sets up a socket, which a UDP socket, which we use to communicate back and forth between C++ and Python to basically say when something's ready to go.
So, Paul, can you expand a little bit on that? It's interesting. So you're using UDP as some sort of communication mechanisms between the Python layer and C++ layer. Can you expand on that a bit?
Yeah, so we wanted to support asynchronous method calls, and we wanted to support that in multiple different languages. So we looked around at the ways of doing that, and the simplest way of doing it was to use a socket, because that's supported in many languages in asynchronous libraries. So we're using an internal socket to communicate between two pieces of code that are both running on the same process but in different threads effectively.
Okay.
So in this case, we're going to make this method call from our little shim library. That calls into the C++ code here, which is on the right-hand side. In order to actually create the database, the first thing it does is it checks to see if the database already exists. So it makes a call out, and you can see that we just sent this call out to the other end, which is a hasDB call. If I scroll up a little bit, you'll see what it actually did here. HasDB. So that responds back. And in the C++ code now, we should have something that says no database, which means it doesn't exist. We can go ahead and create it. So I'm going to make a call to create it. That sends some more traffic. The database comes back. As long as that worked out okay, we end up just creating some internal structures. And then once we're ready, we fill in a result. We then set the result ready. When we do that, that signals the socket, which wakes up the Python side. Is the Python code again. It can now close the socket and return the response back to the caller, which in this case is our little test script. And then that thing can display what it got. And as you can see here, it got an object that it can now use. So now it can go ahead and create some keys and read the keys. Over here, we just created and read a key, and we've got the result over here. We can do things like a quick read, which is our optimized version of a read without consensus. We can update the key to something else and then read it back, and we can see that the value's changed. Now it's eval1 instead of eval. We can list the number of keys and the size of the database and stuff. And all of that communicates obviously with the back end in order to do that. And then we have a final call over here, which basically gives us the status of the swarm and displays it in a way that we can understand. So this tells us about the nodes and their latencies and how long the swarm's been running and stuff like that. And that's successful run, and that's the end of that program.
Well, that's really fantastic, Paul. So I want to just get a kind of high-level understanding. So it sounds to me like what the Bluzelle team has done is they've built all the really important complex logic for the client library into a C++ common runtime. And now what you've got on Python is a really thin layer that's calling into that C++. So you've basically adhered to the drive principle, keeping all the code in one place. And whenever there's updates or anything, you just modify the C++. And now you have support for Python. You can also support all these other programming languages. How
exactly. Yes. I mean, we wanted to avoid having a native library for every language because that's a lot of maintenance. It's a lot of code to write. Mm-hmm. Using this method, the shim library pretty much needs to be written once, and it's very small for each language, and then all the focus is put on maintaining the common library, which is in the C++ code, and we only have to do that in one place.
Well, thanks a lot, Paul, for that demo.
Thank you.